Good morning, friends. In this video, we'll be covering up Indian climate, chapter 6 of geography section. We'll be covering in such a manner that we need not to study it again. Okay, so let's get started. Indian climate. And first of all, the introductory lines. From here, you can always use certain words which are used for introductions. So, climate has an overall impacts has a great impact on overall development of a country. Then दूसरा you had studied that line है कि nowhere in the world the influence of climate is so much on the development of a country as it is seen in monsoonal countries, and India is a tropical monsoonal country. Okay, so you can utilize this line. ठीक है. Then there is a characteristics of Indian climate, that is, though we say it tropical monsoon type climate, okay, but still it has lot of temporal spatial variations in it. Okay, so this provides both challenges as well as opportunity for India uh, from the climatic sides. Okay, then first of all, the difference between a weather and climate. You see, friends, climate is the sum total of weather, and weather is the particular atmospheric conditions at a particular time. So what you expect is climate, what you get is is weather. Then the components of climate. What are the components? One is temperature, then pressure, then amount of rainfall, humidity, and then direction of winds and velocity of winds. These are elements. Then what are the factors which influence it? What are the factors in we look it from the perspective of Indian context. So what are the factors which influence our climate? So it's longitudinal latitudinal extent of India. It is around 30 uh, degrees in both east to west and north to south. So longitudinal latitudinal extent is very high. Then distance from sea. Three sides on India. It is being surrounded by sea. So in various coastal areas, sea has a moderating effect. Cyclones play a very important role. Then altitude and mountains. Altitude mountains in our country play decisive role. Say Himalaya stops the winds from Central Asia as well as act a barrier for monsoon clouds. Similarly, Western Ghats play important role in overall climatology of the Western states. In East, we see uh, the topography being highly influenced by the higher peaks of Himalayas and the smaller hills there. And physiography is sum total of all these monsoonal winds. See, monsoonal winds means 180-degree reversal in seasons. Okay. Then upper air circulation. In India, we have mainly two upper air circulations. One flowing around 28 to 30 degrees, known as the westerly jet stream, found explicitly in winters. Okay, and then the summer wise, it flows from east to west. Sorry. Ah, now we come to the easterly jet stream. It flows from east to west. Okay, it is found in summers, and its intensity is directly proportional to amount of monsoon. Okay, we'll cover up all these things in later on in this video itself. Then tropical cyclones and tropical depressions increase or have a direct influence on amount of rainfall a place gets. El Nino is the warming of the easterly of the western Pacific oceans from Indian side. Getting that? From Indian side, if western Pacific Ocean or Peruvian Humboldt current gets warm, then we have an inverse relation to our monsoon. Southern oscillation similarly is related to southern oscillation is related to El Nino appearance itself, and a combination of two. Now this is warming of waters, this is pressure reversal. This the combination of two is known as ENSO. Okay, okay, friends. Now, as I earlier told you, the climate The climate of India is known as tropical monsoon type climate, however has regional variations because of its continental size, topographic variations. Still, in general we can say it a tropical monsoonal country. Now why tropical? Tropical because Tropic of Cancer passes through it. Why monsoonal? Because we see a reversal of winds 180-degree, and these are seasonal in nature. Okay, apart from this we see a lot of other type of climates, say for example equatorial in Andamans, arid in Jaisalmer, then polar in Siachen, hot desert type Badmer, monsoonal in Meghalaya, and tropical savanna type and steppes type, and peninsular India and Punjab respectively. Okay. Now we come to next part. What is monsoon? Okay. Now see, monsoon comes from the Arabic word which is known as mosin or mosam, which means seasonal reversal of winds, which means a type of climate which is seasonally dominated, in which seasons have very different sort of orientations. However, we start defining it, we see the its definition as large scale seasonal wind system. One, first of all, it should be large scale, because anabatic, katabatic, land breeze, sea breeze, these here also we see reversal of winds, but it is on a very smaller scale and on a daily basis. But here has to be large scale wind system that is seasonal. Okay, then 180-degree change uh, should be there over one specific area. Dominant wind in one direction which changes direction completely in another season. Okay, then to sum it up we can say sea to land during summer, land to sea in winter. This is a monsoon is system. Monsoon is a system of seasonal winds, that is sum of summer and winter winds. Okay, in India we see two type of uh, uh, general winds. Northeast monsoon. These are planetary winds. So generally this is the only system which should have naturally, if Himalayas had not been there, northeast monsoon would have been the normal flow throughout the year. However, due to presence of Himalayas or Tibetan plateaus, we see an anomaly southwest monsoon. So these are two types of monsoon we see. That is why we are having monsoonal type of climate. So this is planetary winds. Okay. Okay. Now we come to why such happens. What are the reasons behind it? Z. So first of all, we define, then why and where is its location, why it is shifting, where is this location in summers, then winters, and what effects it have on our monsoon system. Okay. First of all, we shall define it. While defining it, we use the term turf, broad turf of pressure in equatorial regions fluctuating. Okay, pressure in equatorial regions fluctuating along with the movement of sun. Okay, then a zone of convergence of winds, a zone of bending air, depression, cyclone, maximum clouds and heavy rainfall is known as ITC. That is the dynamic zone. Then we come to the location. Location of ITC, apparent movement of sun in the sky. So during summer solstice and winter solstice, it is there on Tropic of Cancer and Capricorn respectively. During winter equator, this that ITCZ is there, and as a result of which northeast monsoon is northeast monsoon or northeast winds prevail. Under polaris course get deflected to become what, northwest monsoon. Then Tropic of Cancer, so it becomes south. This is being told here. Nothing else. That are 22 or 25-degree north going to take place, and it is in India is uh, 5 degrees shift south west direction, and which rainfall and over changing as a result of its tropical depression and intensity of uh, okay, now jet streams. There are two type of jet streams. One is easterly jet stream and another is westerly jet stream. Westerly is in winters, flowing west to east, 13 kilometers from the ground surface and at latitudes of 28 to 30 degrees north. Then there is a easterly jet stream in summers, flowing east to west at a height of 12 kilometers, which is around 15 degree north, so somewhere on peninsular India. Okay, fine. Okay, now first of all defining it. What is tropical jet? What is jet stream? First of all, jet stream is band of very strong winds. Use this word, band of very strong winds moving rapidly moving circumpolar air circulation. Jet stream is a band of very strong and rapidly moving circumpolar air circulation. Okay, band of very strong and rapidly moving circumpolar air circulation found in upper troposphere. Location. So see, what is the point is, location is upper atmosphere. Uh, Characteristic is circumpolar polar air circulation having rapid and strong strength in its velocity. Simple. Then here these two jet streams are told. Here the two jet streams are told. One is easterly, one is westerly. Westerly jet stream is produced by thermal induced high pressure zone over poles. Okay. Here it is being told ki okay, let me tell you the formation itself. So westerly jet stream is produced via two factors. Number one is having a cold temperature or high pressure zone over two areas. One is on the south pole, okay, and then excessive cooling down of Tibetan plateau. So these two Tibetan plateau and south poles cold temperature produces heavy amount of uh, westerly jet stream. It induces its strength. The easterly jet stream is formed by the heating of Tibetan plateau. Now what happens is when Tibetan plateau gets heated up, it produces anticyclonic thermal depressions, which weakens the westerly jet stream, however strengthens the easterly jet stream. Itna hi it has been told in this book. Okay. Okay, then the characteristics is being told कि jet streams velocity and strength is directly proportional, is inversely proportional to temperature. So as the temperature declines of a area, so it is bound to create high pressure, and high pressure in low areas in the lower atmosphere is very suitable for formation of jet stream. So we see in winters there is a high pressure zone created on northwestern Pakistan and northwestern India, as a result of which westerly jet stream gets manifested or has uh, manifold increase in its strength. As and when temperature increases in that area, so that jet stream's velocity would decline. So jet stream's velocity would be directly proportional to the temperature gradient. Remember it. Okay, now we study a jet stream in India during winters. Okay, now jet stream in winters. In winters, first of all, Tibetan plateau bifurcates westerly jet stream into two parts. One is north of Tibetan plateau, and one is in the south of Himalayas. Okay, this branch is which is important for us. Now see, creation I have told you, creation is due to cooling down of Tibetan plateau as well as polar uh, temperature gradient. Okay, now what happens is very interesting thing. First of all, we need to understand what are anticyclonic conditions being repeatedly told here. See, anticyclonic condition is a condition where around a high pressure area, okay, winds are swirling. So it is very, which is clockwise in northern hemisphere. You see, it is uh, complete reversal or opposite of cyclonic condition. In cyclonic condition, there is a low pressure area around which winds are whirling. Okay, so what would be anticyclonic condition? There would be high pressure around which wind would be whirling up. Okay, now during the winters, there is this is that westerly jet stream, which is the bifurcated branch south of Himalayas. Then over northwestern of Pakistan and India, there is a high pressure zone uh, around which these winds are whirling in clockwise direction. Now these winds are responsible for bringing in westerly disturbances, and due to this, since this is a high pressure zone, so winds would be rising and would be subsiding over Indian plateau. Okay, as a result of which, in the entire Indo-Brahmaputra basin or Indo-Ganga Brahmaputra basin, there is a high pressure zone, and being high pressure zone, and there would be a low pressure zone over partial low pressure zone over the Indian Ocean. So winds would be flowing in northeastern direction. Okay, we can understand it through map. So if here is high pressure zone, and this is the circulation of winds, and winds are again whirling out. So these winds would be bringing in the jets, the western disturbances. This subsiding of air over this area would promote or enhance the northeastern monsoon. Okay, jet stream in summer. Now what happens is, during April and May, there is an intense heating over the northwestern India and Pakistan. Now, due to its heating up, it is likely that um, monsoon wind should immediately start coming towards this area. However, due to the presence of westerly jet stream, a part of air subsides over this area, over the northwestern India and Pakistan. So there is a continuity of anticyclonic conditions here, though they become dynamic. Okay, but still there is a presence of this, as a result of which there is no suction of winds in this area. There is no suction of winds in this area from the seaward side. Okay, now as this process keeps going on, yes, by the middle of June, by the middle of June, the sun again comes back on the equator. It's true then. Now what happens is, the amount of temperature gradient which is on north pole declines, as well as the Tibetan plateau gets highly heated up. Now both of these factors weakens or completely ends the westerly disturbance. Now as there is a complete sudden disappearance of western disturbance. Now we look at, okay, now suppose suppose this is western winds flowing, this is ground surface which is being heated up. Now as this wind suddenly disappears, but this is highly heated and warm air. Now no air is subsiding, however this area becomes empty, so it suddenly sucks all the air, because there is a sudden disappearance. So this air present on the surface of this is northwestern India and Pakistan. Now since this air is already heated up, there is no air here because western disturbance is disappears. So this air is sucked up, and there is a sudden formation of highly low pressure area in this area, as a result of which we see a lot of storms and monsoon burst is seen in our country. Now what happens is, along with this process going on, disappearance of westerly jet stream, we also see that ITCZ also is shifting in this process. So ITCZ would again very soon be coming, say by the end of June, coming to this belt. So it would be somewhere nearer to this, and then it would be this would be and this would be the ITCZ. So the winds would be again deflected. So this would further intensify the low pressure area, a low pressure area are present in already present over northwestern India, and as a result of which wind would be further coming here. Now we look at the role of Tibetan plateau in our country. Now see, there is two roles. One is acting as a physical barrier, and then there is a high level source of heat. The physical barrier, I told you ki this bifurcates the westerly jet stream into two parts: southern westerly jet stream and northern westerly jet stream. I told you. Then I also told you that source of heat. Now it has dual role via source of heat. Since air is thin on higher altitudes, so warming and cooling of land becomes relatively easy. During winters, this cooling down of westerly jet stream promotes the the southern branch of westerly jet stream, and makes its intensity more stronger. Okay, in the summers when it gets heated up, so when it gets heated up, it creates anticyclonic depressions, thermal. It creates thermal anticyclonic conditions which are dynamic in nature, which weakens westerly jet stream and replaces it with easterly jet stream. Okay, this mechanism has not been told, but this is being written here. Okay, along with this, what is being told is ki, since it goes from 15 north in a from east to west, also the winds moving here subsides over Africa, somewhere here near Madagascar. So what it does is it creates a low pressure in this, high pressure in Africa. Winds gets promoted, so this monsoon gets promoted with higher intensity. So it is said ki higher is the intensity of, now we cover the El Nino process. Okay, you can add while writing answer is cool and shallow, while over Western Pacific the current is warm and deep. Then there is a Southern Ocean and Eastern Pacific. This is Eastern Pacific. Sorry, this is Indian Ocean and this is uh, East Pacific. Since here cold current prevails during normal times, so pressure is higher and low pressure fluctuates or changes during El Nino process or due to some any other reason, uh, it becomes highly detrimental for monsoon. When El Nino and Southern Oscillation happens simultaneously, it's known as ENSO, El Nino Southern Oscillation. Okay, it's simple. Of ocean current, while Southern Oscillation is about air pressure. Okay, this is where we end this first part of our video. We'll be covering rest and other videos will be relatively